was basically an incubator for new companies to develop their technologies so that in the future we would have a next generation of power generation.
Did the state work with any other colleges?
All over the states, yeah, yeah. So it is really awesome. So this was the first center that was built. It was purely a incubator. Stark State didn't have any space inside this building. It was all companies. And fortunate for us, the first two companies to occupy that space were the engineers from Rolls-Royce and Sofco. And very quickly, the two companies realized, wow, together, we can change the world. Seriously. Because one had a fuel processing expertise that was really incredible. And one had a fuel cell technology that was just as incredible. So they decided, hey, Stark State, we don't want you to let anybody else come into these bays. We want to lock the doors. We're becoming one. And Rolls-Royce bought Sofco. And that's the same Rolls-Royce that makes jet engines. The same Rolls-Royce's name that's on vehicles, but they're not really, Rolls-Royce really isn't in the vehicle business. They sold that brand, but they're really known for their jet engines and propulsion. So the next step was, okay, now we need to build a prototyping center. So we have this great technology that we have tested and verified in a smaller scale. Now we need to increase that. Now, as I'm talking about this, do you kind of hear a lot of engineers in your mind? There's a lot of engineers that made this all happen. So what the next expansion was in 2009, we actually added 23,000 square feet so that they could put in their prototyping center.
Is the project like given to one company and then like that company calls other people like to come in and help them with it?
Actually, in this case, this was developed by the company itself.
Okay.
So the reason why they needed to expand is that Rolls-Royce actually had centers for fuel cell development in England and Singapore. But they realized that this technology in marriage with Sofco was really just revolutionary. So they shut down, for the most part, their operations in England and in Singapore, and they moved all of the test equipment from those locations to North Canton, Ohio, and installed it in this new building that was built. And then made this the world headquarters for Rolls-Royce fuel cell systems. Now the benefit to Stark State in this expansion was, you see the little green area in the corner? That's when our fuel cell lab was built. Because they also realized that we have just this number of people that know about fuel cells, but we need the next generation of engineers because we're growing and nobody knows anything about fuel cells for the most part. Even though they've been out in the market for over 50 years, this technology was brand new. So we really needed to develop curriculum and expand. And this is where the project that I am on kind of started. There was a pre-project before my NSF Great Lakes Fuel Cell Education Partnership that helped to develop the first curriculum for these engineers that then were interns at Rolls-Royce, and many of them now are full-time employees at Rolls-Royce. So then they realized, okay, this technology has been tested out. It really is proving successful. We're getting closer to commercialization. We need 30 more engineers. We need to expand. We also need capital. We need an integrator partner. So what happened? LG partnered with Rolls-Royce, and you now have LG Fuel Cell Systems Incorporated, which is 49% owned by Rolls-Royce and 51% owned by LG. The same LG that you might see on your television, on your dishwasher, on your washing machine, on all kinds of different electronic components. So, can you imagine what sort of expertise LG brought to the table? Looking back to the slides of the kinds of engineering jobs that there's so many different types. Supply chain, logistics, manufacturing. So it really was a good marriage. And also, another increase in opportunities for engineering. So, up in the corner, you see they added, surrounded by yellow, the engineering offices for that commercialization team. That's the team that is designing the overall package for the system that has been developed. They're doing the feasibilities on manufacturability and repeatability. Because while you can create something and test it and verify it, now you're going to need to make 100 of these. And you've got to make sure that the first one is as good as the 100th one, and that the components are perfect for each one. So it really takes not just a handful of engineers, but a little bit of a city, in a way, a village. And the benefit to this expansion was also that Stark State has another lab now, another 1,000 square feet, to focus on the renewable energy and particularly solar energy and electrical training. So the total facility now is 60,000 square feet. And the kinds of positions that are in this building of LG Fuel Cell Systems Inc. are design engineers, manufacturing technicians, controls engineers, test operators. Yeah.
With your facilities being so big, how do you keep track of the energy is supposed to protect the environment, but the things that live in the environment are being misplaced too when you build your facilities because they're so massive. And if you guys want to do this and it works, then everybody would want to do it, which would mean there'd be hundreds of facilities.
Yeah, you have to, you're mixing different technologies right now. Yes, sometimes birds and bats do get killed by wind turbines. Did you know that more birds and bats get killed by windows than they do by wind turbines? When wind turbines are placed, a tremendous study is done on migratory paths as well as habitats to make that impact as low as possible on the environment. Now, frankly, some of the early farms unfortunately did not do that. And where wind energy got a really huge egg in the face, and it took them back quite a ways, is one of the largest wind farms in the beginning actually was put right in the center of a migratory path, and it was a bloodbath. It was really bad. They learned a lot from that, and today it won't happen. So, for example, we will not have a wind turbine at the corner of Schuylkill and Frank. Not because of the airport, because the clearances are okay. But there's a special protected species of applebat that lives in the woods behind the facility. And we will not take the risk of hurting that habitat for that applebat, or killing that applebat. So we do take those things into consideration. Now what you'll see is that the system that LG is producing isn't that big. It isn't invasive to the environment. And actually it protects the environment over coal-fired burning plants.
Regardless, it's the environmental damage done by these are negligible compared to coal and natural gas.
Exactly, exactly. So this picture gives you an idea of the size and scale of a 1 megawatt fuel cell system. It is basically the size of a tractor trailer. It's not a big generation plant like you're used to seeing. So it really does actually minimize the footprint and minimize the impact on the environment. And even better, it doesn't have the NOx and SOx emissions. They're zero. Yes, there are still some carbon monoxide exhaust, but not near what any other power generation has. And I won't go into detail on the particular system, but if anybody wants to talk about that separately, I will. So in order to develop those future fuel cell engineers and technicians, Stark State has fuel cell degrees and certificates. The Mechanical Engineering Technology Associate's degree with a fuel cell major is a tagged curriculum. And many of the engineers that have taken this curriculum have gone on now, and I know of at least 4 engineers at LG that started as students at Stark State, that interned, engineering internships while they were going to school, went on to Akron U or other colleges and have completed their engineering degrees and are now full-time employees at LG. I know actually of 11 of our students that are full-time employees that didn't necessarily intern with LG, but because of their fuel cell knowledge and because of their background are now full-time employees. We also have a 1-year certificate that's focused on the fuel cell technology for either an engineer who wants to come back to get that special fuel cell knowledge, or a engineering technician that would like to be able to be a test technician. And we have a few individuals that are full-time employees at LG now that went through this program and became fuel cell technicians. And then we have the Fuel Cell Certificate of Competency. This is predominantly what those returning engineers come back to take, because they already have all of the curriculum under their belt of what the 1-year certificate would have. So they'll come back in just for a specific class or 2 focused in the fuel cell area. We also have other courses in the renewable alternative energy curriculum that I had mentioned before. So we have a sustainable alternative wind energy 1-year certificate, and then we have a wind turbine maintenance 1-year certificate, and we have electrical maintenance technology associate's degrees, one with a wind major and another with a solar major. Now, I had mentioned that we do have the education partnership that is a collaboration over 6 states of 11 different colleges and universities. And our website, which I'm going to give you each a card that you can visit, has a lot of good educational information about the fuel cell industry and about how the fuel cells work. So I'm going to kind of page through this because I've got a little simulation that I want to show you. So what I also want to show is that there are actually, a lot of people think the hydrogen economy is something way in the future. Truth is, there are hydrogen fuel cell buses already in operation and have been in operation for quite a long time. The challenge we have in Ohio is we don't have the infrastructure, but it will come. It will come.
Where are these available now?
These buses are already running in places like Washington State, Connecticut, California, Honda, Honda, Hyundai, and Toyota are commercializing their hydrogen vehicle in 2015. If we all know about commercialization and model years, that means they're actually going to be selling those cars in 2014. And believe it or not, those Hondas, some of them are going to be produced in Marysville, Ohio. So I think very soon we're going to be on that hydrogen byway. And I'm collaborating with SARDA to try to gain approval and support for building that hydrogen infrastructure. That question in the corner?
Yeah. So this new energy, it brings a lot of change, but one of the things that makes our economy so strong is that we have a lot of oil here. So how do you expect to prevent political pushback from those big groups that generate a lot of money from fossil fuels? Like, how do you, I know there's a need, but money talks a lot in the United States.
Well, the good thing is that we've got the Department of Energy on our side. So, yes, you're right. Oil companies are gonna push back. It's their bread and butter. But they also realize that there are environmental issues, there are sustainability issues related to supply. So, for that reason, you're gonna see it moving forward. Is it gonna move forward more slowly because of the amount of gas that has been found? Absolutely. Absolutely. That'll slow down the deployment, but it won't stop it. So, a lot of people think fuel cells is a new technology. The truth is, it was actually invented way back or identified in the 1800s, late 1700s. And an actual fuel cell was built by Mr. Grove in the 1800s. And further developments by Mr. Mound in 1889. Now, what was holding it back? Cost and emissions from the early ones. And what pushed it forward, beyond Mr. Bacon, was space. We needed a means of reliably producing power, water, and so forth to support life as we went to the moon. So there was actually a fuel cell right there on board in the Apollo spacecraft that provided that, served that function in the spacecraft. Now, the difference is, again, the technology was there, but the affordability of it at that time wasn't there yet. But we've learned a lot from the space program to make it cost effective so that it can be used on land as well as in space. So how does it work? Basically, you use hydrogen at the anode. We use a catalyst, we split the electrons from the hydrogen. The hydrogen becomes positively charged, as you see. It reaches the anode, or the cathode, merges with the oxygen, O2, and your exhaust is water. So you're producing or you're using the electrons to light the lights. You're basically borrowing the electrons from the hydrogen. And this is a very important concept because when you think about transmission of energy, you have a lot of transmission losses. So for example, if you have a wind farm in the middle of the farmland, you might not have the grid that goes there. And it costs millions of dollars to lay that infrastructure to then transmit that power. But you have another option. You can use that energy to produce the hydrogen through electrolysis and store the hydrogen and then transport the hydrogen. So that's another option.
And the only significant byproduct of
A
fuel
PEM,
cell?
of a PEM fuel cell, and I'm going to show you another one next. So this is the PEM technology. This technology works very well for portable systems. So the vehicles that are hydrogen powered are this kind of technology. The portable systems, the backpacks that the soldiers use, will be this kind of system because they're light and they're effective. But they're not very effective for major power. So for major power, we need a system that doesn't use hydrogen, but uses a combination of other gases or fuels. And the experiment that we're going to do over on the right is exactly this type of system. So the solid oxide fuel cell system is a different technology. So here, what is happening, and this is what the LG principle is that they're taking natural gas, they're synthesizing it, and then ultimately what is passing through the solid oxide fuel cell tubes is a combination of hydrogen and CO. And what you can see is you get many more electrons that way, and this is how you can get, a megawatt scale of power in basically a footprint that's not longer than the length of these tables. So this is critical. And it's also extremely reliable and more efficient than other means of producing energy. There are also other types of fuel cells, and I'm not going to go into detail on those, but when I met with you last, I gave you a sheet from the Department of Energy, and I see, Jack, you have one there. And this has on the back the list of all of the different types of fuel cells. And on this, then, you'll see the ones that are appropriate to transportation and those that are for main power generation. So this is what our grid is going to look like a bit in the future. You're not going to have just one big central plant supplying all the energy. So instead, you're going to have combinations of photovoltaics, solar, and so forth. Now, this is why we're doing it. If you look at, you have 100% of the energy at the beginning of a coal-fired burning plant. You lose 65.5% in the generation itself, so, which means you've got 35% left. You lose another 4.8% in the transmission, got 30% left. And then when you step it down from those high power lines down to your house, you've got another 5.1% loss. You end up with only 25% of the original potential. With a fuel cell, you're in the neighborhood. You don't have to have those high transmission lines. You get 60%. And to your socket, you get 55%. So this is why fuel cells are so important. Now I'm going to send these links separately that give you just more background. There's some nice simulations of the combination of solar and wind and so forth that you can look at here. And also there's some tremendous resources on all of those positions and career opportunities within the energy sector. They predict that within the next 10 years, 50% of the engineers in the utility industry and power sector are going to be retiring. So there's some great opportunities as you come out of college for that. And again, this is just more background that I'll share with you. So, is there time to do the experiment, or?
How much time do you need?
Would only take maybe 10 minutes. Is that
10
right?
minutes you have.
Okay. Okay. So if everybody'd like to get up, I'll grab a couple of lights and we'll do a little
Hey, how you doing, Mr. Creel?
Okay. You're gonna need some of the setup people.
It's gonna move right around you guys. You could be with a group, so you separate. One of you go with one group, one would you go with the other, and you're just gonna watch. You're not gonna touch it. So you go with the groups, and you pick out who you want to sit with. Okay.
And then this week, I'm actually in town. I'm in town.
You come over here with me.
Hi, honey. You see what I'm doing right now? I'll pick a group for you. Okay. How about this? You just walk around. Let's put this down. Yeah. Okay. Just walk around and look.
See how you're gonna set yours up with water. We're gonna start by filling up the vials to the 0 point with distilled water. Then somebody wants to read this over to them. Okay, so pull up your vials and fill up your cups to the 0 point. Then what you're going to do is to take one of the domes and you're going to set it down in the water with a little notch such that it's not covered by the little plastic half moons that are in the bottom of the. And you're going to put the, if it's still connected to your fuel cell, you're going to put the black side connected to the H2, and the red side connected to the O2. And again, you want to make sure that that little cutout is not covered up by the little, I guess there'd be a little bit of a quarter moon in the bottom of the cup. Okay. And then maybe somebody else on your team there could take your lamp, and I'll run the cord down so you can actually put your lamp on if it will fit. It's not You can actually use it, you can actually lean it on your bottom.
Turn that van away.
Okay, so you got your water. You're not a gentleman. You guys go. Okay. I still
Too expensive things right now.
I know you're going to Bronx. I'm going to two Bronx. Which one are you going? I knew you were gonna do that. I knew it, and I didn't react that. How was it?
Are they supposed to be on opposite sides or no? That doesn't matter. Output, input, you had from the same side.
What are you looking for?
I didn't know if it came from opposite sides, like from input to output.
Actually, you don't even need to use your monitor for now. But pull out your solar panel. Yeah. It's this, and this is the stuff for your fuel cell.
I guess so.
The one.
Going into politics, so don't worry.
Wow.
Yes, we need light. A red wire, so take your solar panel, take a red wire and a black wire, plug the red wire into the red notch and the black into the black, and then plug it into your circuit board. Again, red to red, black to black.
Is that far enough?
Okay. And then into your
Actually, let's just do that. There we go.
The red goes to the O2, so know that.
I know that the black goes with the black and the red.
The red goes with the red. It's not plugged. Oh, it is.
There.
How many two systems?
Yeah, like I don't understand.
That. Maybe they plug it right there.
There's more cords over here. Yeah, I think cords in there as well. I feel as though there's not a connection. Have another monitor. Are we gonna plug the wires? Yeah, we're gonna extend it.
I'll see if it works.
I don't think it will.
Let's
Nothing connected to anything.